Hi guys, so welcome to this second video for Unit 6.2 of Paper 3, which looks at environmental risks. In this video, we'll be thinking about various methods that are available to reduce the effects of acid rain. You need to watch this video in conjunction with the departmental website. On the department website, you will see some detailed pollution about how to reduce the effects of acid rain. But first of all, to help you to understand that, you'll have a watch of this video.
Originally, people tried to neutralize the acidity by adding limestone to the lakes. This was partly successful. For example, salmon returned to some polluted rivers in Wales after the acidified lakes from which the rivers flowed were treated with lime over a number of years. A much better method is to trap the acid before it reaches the atmosphere in a process called scrubbing. The kind of scrubber we need in this case is an alkali to react with the sulfur dioxide. So either seawater, which contains a little bit of sodium carbonate, or lime, calcium oxide, is used. Can you think what reaction will occur with calcium oxide, a basic oxide, and sulfur dioxide, an acidic oxide? Calcium oxide plus sulfur dioxide makes calcium sulfite, that's CaSO3. The sulfite can be reacted with oxygen to make gypsum, calcium sulfate, CaSO4, which is the main ingredient of wall plaster. These scrubbers have greatly reduced our sulfur emissions and given many countries much cleaner air, but it does reduce the efficiency of the power station, maybe by as much as 10%, thus increasing the cost of the electricity. In oil refineries, sulfur is removed from crude oil by reacting it with hydrogen. This reaction, known in industry as hydrodesulfurization, takes place at high temperature with a metal catalyst to produce hydrogen sulfide, that bad egg smell and a very poisonous gas. When this purified oil is refined into various fuels, it is virtually free of sulfur. What about reducing the amount of nitric acid in rain? This time, we need to put catalytic converters in the exhaust pipe of all our motor vehicles. Essentially, they convert the oxides of nitrogen back into oxygen and nitrogen. It is a pity we have to do this because we use huge amounts of fossil fuel energy getting nitrogen to react with hydrogen to produce nitrogen-rich fertilizers. With a little collector in all the exhaust pipes, we could deposit a little pile of fertilizer every time we fill the fuel tank. There's an idea for one of you young entrepreneurs. So to summarize, the best way to reduce the effects of acid rain is to prevent the oxides of sulfur and nitrogen from escaping into the atmosphere in the first place. This is done by scrubbing the exhaust fumes from power stations using lime or seawater to remove the sulfur dioxide, and by fitting catalytic converters to motor vehicle exhausts to decompose the oxides of nitrogen.
Okay, right, so I would encourage you to go directly to that Fuse School to have a look at that video as well directly in YouTube. So there we can see that there were some attempts to reduce the effects of acidification by adding lime to the lakes. Obviously that's very expensive and very inefficient, and it's much better that you stop those pollutions from getting into the area in the first place. Some examples there of gypsum being generated by the scrubbing process. Gypsum is actually quite a useful mineral, and it is used in the construction industry. So there again, you guys have already looked at the circular economy. So this is a good example of a circular economy. And then theoretically, the video suggests in the case of catalytic converters, you can collect the nitrogen from the catalytic converters for fertilizer, so you can use that to fertilize your garden. We haven't got that technology yet. Whether or not it's viable, we don't know. But there are two examples there of a circular economy. Now, of course, you will realise that what this does require in the case of transboundary pollution is cooperation between countries, and international law is extremely complex and extremely difficult to enforce. And the point there that it can reduce the efficiency of power stations by 10%. The country, if we're talking about transboundary pollution, and in particular if your power stations are on the border of your country, and the prevailing wind takes most of that acid deposition away from your country and effectively dumps it in another country, there's very little incentive for you in economic terms to actually scrub that. So you are paying for it, but in the case of transboundary pollution, your country doesn't benefit directly from it. So it makes it extremely difficult. We've already looked at the case study of transboundary pollution with the burning of the Indonesian peat beds, but we will take another look at one, which is Kanja. So again, just to be clear, the chemicals that we're talking about here are sulfur dioxide and nitrogen, and they've been emitted by industries such as coal burning. The United States does still burn a lot of coal, although thankfully that is starting to be reduced. But the weather, those prevailing winds, does export or blow the pollution across the border into Canada. And that's where between 50 and 70% of Canada's acid rain actually comes from the United States. Working in the opposite direction because of the prevailing wind, Canada to America, it's only 2%. That's because there's considerably less industry and population in Canada, but also because that's the prevailing winds blow from the United States to America. So you can see the effect here. 31,000 small lakes have a pH value of about 5. That pH value you'll remember from your coursework. It's absolutely critical because it's at that stage that the eggs of fish and aquatic life start being affected. So things are getting better. They are starting to have some international agreements. The Environmental Protection Agency is starting to clean up their act. So in the last 20 years, it has got better, but we still have a ways to go. Okay, guys, so in the next video, we're going to have a look at the environmental impacts of global flows. Hope you've enjoyed this video and found it useful for your revision.